Okay, welcome back to part 2 of programming concepts and skills. So we're going to jump right in here. Just as a refresher, we talked before about practice number 4 from the computer science frameworks, developing and using abstractions, which involve generalizing from patterns and features to create solutions. Oftentimes this is looking at data, sometimes quite a bit of data, and then coming up with solutions and analyzing the data, making conclusions, those kinds of things. But generalization, we're looking at making complex stuff simple. So that's the goal here. Just to give you an idea of where you want your kids to be after K-5, and then when they're big kids graduating high school, they should be able to extract common features, evaluate, incorporate technological functionalities, create interactive modules, and then model scientific phenomena, processes and systems, not necessarily scientific, but just model stuff. So that's what we're shooting for in terms of developing and using abstractions, and by the end of 12th grade. So for our purposes, we're looking at algorithms and programming. So this is a concept in the computer science standards. Programming being writing step-by-step instructions for a computer in a language or code it understands. So whether that be Scratch, Java, Python, similar to Spanish, Latin. Latin would be more akin to HTML, but French, just different languages, and then how do those languages work so that they can be understood. Algorithms, we're talking about sequence of steps, and then the control structures tell the order of those steps. So we're going to focus today again on events, loops, and conditionals. Events being actions that cause something to happen. Loops being actions that do something over and over again. And then conditionals specifying actions only under certain conditions. So if X, then Y kind of thing. All right, so let me get out of this and share my screen with you. Okay, just want to check with folks in the audience to make sure they see my screen. Do you see my screen okay? And we will pick it up from here. Okay, so before we talked about research on these code.org lessons, and that if students actually engage in extra lessons, at least how this study defined them, then there were significant gains in ELA, social studies, and mathematics, I believe. So the goal here is to have students to do these lessons, learn these basic skills. I think the reason why these lessons can result in learning in other subjects is because over time, as students practice skills and practice different ways of learning, in this case computational learning, then they begin to make connections to that content and see how those skills and relate to skills in other subject areas. So particularly in math, computational thinking around math. So just to remind you, these are all free, and this is the course catalog, go all the way up to the university level, and in K-5 we've got all kinds of lessons that can be implemented in your classroom. So these are fundamentals lessons, course A through F, and we're going to focus on D today. And then what we're going to do is I'm going to go through those lessons again and really drive home how these lessons can, and the concepts and skills that are learned in these lessons can be applied to Scratch. So code.org has the lessons structured for the teachers, ready to go. They're scripted. They're, just canned and easily implemented in the classroom. Now, what you do with them and your creativity involved in that is up to you, but they're ready to go, and they can serve as an infrastructure or backbone for students learning concepts and skills in computer science, and then applying those to other types of activities or projects that you want to do. So that's what we're going to do today. Looking at my studio, remember the profile here. This is K5 Coding, and the studio is computational projects once you're on that site. Let's look at lesson 3. We went through this one before, and just to refresh you, we're going to hit that again. So attach a block to when left arrow and press run. And the goal is to move over to this flag. So we're dealing with movement here, and we're looking at the control flow being focused on events and movement. So I'm going to start with moving right again, and then move left. I'm going to run this, and nothing's happening. Let me put another one in there. Oh, I gotta hit this. So pull this out. So when I'm pressing the left arrow, nothing is actually occurring, because I'm moving right and then left every time this happens. So instantaneously I'm just moving and then moving back. And then if I put another script in there, now I'm just moving right. So goal here being, I want to move left, reset this. All right, this is weird. Okay, so now I got a smiley face, and then I can continue. All right, so just to give you an idea of how this applies to other languages, in this case it's block language like Scratch, and the idea is the same. The functionality is very much similar. So this particular project, it's a soccer project, and I can move the ball. So basically my controls are managing the movement for me. Although they are, there we go. And then bounce me back. Go to the other side. Okay. So you can see inside these and see how these were programmed. Gotta actually click on the balls. You can see when right arrow is pressed, it's going to point in a particular direction and move 10 steps. Up arrow, point in a direction, move 10 steps. So the movement is the same magnitude on the X or Y axis there. It's another project that shows similar kind of thing. I love this. Can you please love it so it will encourage me? And so people actually were providing comments to the scratcher. All right, so what's happening here is just control flow being focused on movement left and right. And I'm just pressing the arrows here. Let's see inside. So you can see if up arrow is pressed, change Y by 5. So when I press, I'll start this thing again. When I press up, it's going to move up by 5. Let me start over again. So you notice here, it's at 180. Press once. I've got to point to it actually. So right now I'm at Y equals -13. And then I went down 5, up 5, up 5. And you can see Y moving by 5. X, same kind of thing. So you can see the mathematical relationship here, especially with graphing. All right, so this is actually a loop, but it gives you an idea of how an event just in, if one particular command is executed, something happens, and you can actually change that into a loop. So just want to show you a project that I pulled together today. Got a baseball, and I actually have a background. Let me let you see the code. The background, the backdrop, is a graph. You can actually find backdrops from the library. So I could change this to, well, it's baseball, so let's just choose this one. And so now I can move the ball along the baseball field. But I wanted to focus on using this XY grid because cool thing is that you can show the relationship between movement and graphing. So as often as you can for in the math standards, they have measurement, observations, and then if you can transfer that into graphing or reporting that data, then that's going to serve your students exponentially. I taught science at the high school level, and I can't tell you how many times I had to go through this, even with honors and gifted students, just being able to graph properly. So that's the backdrop. Let's focus on, let's see, look inside here. So what I've done is I'm just making movement on the XY plane. Get out of this and go to the original one. Okay, so all right, so what I did here was I basically took these events and used these commands. So when the arrow is clicked, when space is entered, when the right arrow is pressed, then X is changed by 10. So press once. That should be X is 10. Press twice. X is 20. 25, and so on. So you could see how you could use this to have students actually graph through Scratch, or to follow a particular pattern, or to understand where an object is on the XY plane. And then this is transferable to robotics. The Lego Mindstorms, for example, uses the same language. So imagine that, do this again. So what's happening here is that when I start this, my baseball is wherever it was before. So I'm going to get rid of this stuff. So when the green flag is clicked, what I want to do is I want to have my baseball go to 0, 0. So when I click that, it goes back there. I could change this to be 125, 30. So that's where I will start each time. So you can see the application here, the computational thinking, and then how that relates to mathematical thinking, mathematical practices. Okay. So looking at this again, just to show the connection. When left arrow is pressed, I move left. And let's run this. When left arrow is pressed, I move -10 each time. It could be -1. This doesn't show you how you can imagine this being an XY plane, same backdrop, how far over to the left this is actually moving. But captured in here is negative something in this code. Okay. All right, let's look at loops for a second. Going back to, get rid of some of these. Okay, so this is going to be great. Help the bee collector collect all of the nectar, all right? So when I'm running, I'm going to move forward. Oh, only move once, so let's do it again. Okay, so I move twice. Then I need to get nectar, right? Okay, got some nectar, but I stopped. So I need to move forward again and get nectar. Got it, got it. Okay, then I need to turn right and then move forward. Let's make sure I turn the right direction. Ooh, okay. Turn right. Then I need to move forward. Okay, on the right track here. Move forward again, get nectar. I'm just curious about this. Move forward, move forward, move forward. That shows you the code. Okay, so move forward, get nectar. Move again, get nectar. I need to collect the right amount of nectar. Let's do it again. Oh. All right, is that it? Okay. Then I need to turn right again. I need to move forward 2 spaces. Get nectar. Then move forward and get nectar. Okay, now we're rocking and rolling. All right, but it's telling me that I could have only used 15 blocks. No! Let's go back and see if it saves. Okay, so it saved. Here I can use a loop. That's what we're focusing on. I've got notice that these are the same. That's the same as okay, it looks like I duplicated that. Or I think I had to get nectar twice, that's right. Okay, I got it in there. So notice these are the same. So that means that I can, and then I turn right each time. That would be up here. So I can repeat this. All right, let's see what it does. It's going through, repeating. Okay. All right, so that's a loop. So the goal is to be able to identify common code, replicated code, and repeat that. It stopped over here. It really should just been repeated 3 times, but you get the idea. So as students go through and learn these skills, how to move, how to turn, and then how to repeat that, in this case in a square, and then to actually do something whenever one is at a particular place on the X or Y axis, then they can begin to build their own projects in Scratch. So that's what we're talking about here. All right, so this was a project that I just played around with today, created today. And understand, I'm not an expert coder here. This is something that I've just learned over time, just actually just experimenting. So same kind of thing. What I tried to do was replicate these flowers, and then an action that occurred if I'm touching this, then something happened. So in my case, I've got my little scratch cat. He's moving forward. He's going to move a certain 1, 2 places. When he hits this, or she hits this, then something happens. Instead of getting nectar, the apple, the scratch cat is actually going to eat the apple, and it's going to disappear. So then you'll notice that the scratch cat turns, and the same kind of thing. So let's just see if this works. Okay, so now cat's upside down, eating some apples. All right, so let's see what's inside. So what I have going on is when the green flag is clicked, it's actually going to wait 2 seconds, move 50 steps, wait another 2 seconds, then move 50 steps, same thing, and then turn 90 degrees. So then I have the same pattern going on. Let's see what matches up. This is just kind of extra over here. So just ignore that. Turn 90 degrees. Okay, so we've got some common code here, like code that we can duplicate. So I think that's what I did here. Let's see if this works. So you can see this is lit up, and that's what's actually happening now. Okay, so move, I have the movement, but I didn't have turn 90 degrees. So let's go back. Looks like this I'm going to repeat twice. So let's just do this. On the control, so just to refresh you, if I double click on this, this shows me each sprite and tells me what it's going to do. So going back to the cat, I'm going to do repeat. I'm going to repeat this twice. I'm going to put it in a loop. So now you see same thing's happening. There's the turn. Turn again, and then it stops. So let's do 3 times. Okay. All right. So you can see that this loop actually took care of all of this code because it was repeating code there, which is what this was. So in this case, I just applied the skills that I learned and played around in Scratch and actually tried to duplicate that to a certain extent. All right, let's look at conditionals. Okay, so this one, I've got to cloud is blocking. I'm just going to choose something. So you notice here, let's go back. When I press run, I'm going to move forward 3 times. That's going to repeat 3 times. Then if I'm at this flower, I'm going to get nectar. Okay. So here it's a little more complicated. I'm going to move forward twice. Then I'm going to turn right. Then I'm going to move forward twice. But I missed the flower and the nectar, so I'm going to put a conditional in here. If I'm at a flower, then I'm going to get nectar. Let's see if that works. Nope, because this was at the end. So let's try this. Nope. You notice that these flowers change on you every time. Let's try now. Well, it's not working either. Okay, so you see that I've got to come up with a way to actually, if I'm at a flower, I'm going to get nectar while I'm moving forward. So let's repeat this a couple of times. If that flower get nectar, see what happens. Nope. Let's try 2 times. Okay. And so what happened was that I wasn't able to actually get the nectar when I reached the flower. So these are the things that students will grapple with whenever they're trying to figure this out. Let's look at how they could actually apply this in Scratch. So if you remember, this was, I showed you this earlier. Compare it to, let's see, I gotta go to my stuff and my studios. This is my studio here. All of the projects that we've talked about and I've used as examples are here. So open this in a new window so you can see it. Earlier I showed you moving the ball. And it's going back and forth, up and down, that kind of thing. All right, and we can see the code here. So if up, change by y, if down, change by negative y, and then 5 and negative 5. So what I did here was, and students can do this, you can actually, we talked about this before, how you can remix your own projects and use those as examples to use for students, those kinds of things. So let me just go back here so you're not distracted by the code. So I remixed this. I actually just opened this project and then I remixed it. I changed the code and still have the same functionality. So still up and down, left and right. But now there's a line there. And what happens when I go to the line? Okay, so let's see what happened with the code. The line actually in the ball. So what I did was I used this conditional. This is repeating forever, but if up arrow is pressed, then this, you notice all of these conditionals. If something happens, and you can find these on the sensing. if touching something, if touching color, here a mouse pointer, an edge, if the distance to the mouse pointer is so-and-so, if key whatever you want it to be is pressed, those are some things that can cause these conditionals to be modified. So what I did was I just put another one in there. And now I'll put if touching, pull it out for you. If touching the lion, which is here, and I can pull anything in there. Let's see, what's scary? What animals are scary here? That ladybug looks pretty scary. Let's pull her in. Okay, so I've got a ladybug over here. Go back to my sprite. If touching lion, let's say, I can actually just duplicate this, right click, but now I'm going to say if touching ladybug. Then I'm going to say something. I put yikes. I'm going to say, whoa, a scary ladybug. So I'm going to say that for my sprite is going to say that for 2 seconds, and then I put motion. I actually chose glide because it just looks a little cooler for a certain number of seconds, and then I chose the XY. And so here you can see wherever I point on the backdrop, it shows me what the XY is. So I just chose an upper corner. So with the ladybug, I'm going to say that when the ball is touching the ladybug, it's going to be over here. What does it look like? Negative 225-ish and 160. Negative 225 and 160. So again, making the connection between the XY plane. This is 0-ish in here. I actually centered my sprite, my baseball sprite. Oh, no, they did it for you. When that's clicked, it goes to 0, 0, 0 anyway. So if touching ladybug, it's going to glide over here, and then I'm going to hide that ladybug. And I'm going to keep in. Oh, wait. Let's pull this thing out, didn't I? I'm going to keep my lion. All right, let's try this. So, got the movement up, down, right, left. I know if I didn't mess this up, when I touch the lion, takes off that way. Let's start over. Actually, I have to, if you notice here, the baseball, because it disappeared, it hid when I touched the lion. I have to show it again. So I changed it to when space is pressed, I can show. So then let's see if the ladybug works. Whoa, scary ladybug. And then took off the screen. Okay. So those are some applications, again, of events, loops, and conditionals using the code.org lessons and then applying that to Scratch projects. And so, you know, in these examples, I just replicated or tried to replicate what was happening in the code.org lessons. So, you know, giving your students some parameters on creating some particular project, giving them, we know with project-based learning that students gaining that sense of control in what they're creating, and parameters that scaffold the skills that you want them to show will motivate them. So, you give them just enough to where they're using their creativity and that getting that intrinsic motivation, then taking it to that next level. So, it doesn't necessarily have to be a replication of what's happening in code.org, but applying those lessons, the skills and the concepts that were learned, and then applying that to Scratch and giving them some freedom in creating their own computational projects. Okay, that's all I have for today. We'll see you next time.